Hi everybody, I hope you guys are doing well today. So we're going to shift gears a little bit here and we're going to spend some time working with solving right triangles. I wish we had a lot more time to work on this than we do, but we're going to make the most of it. And let's just do a quick 30-second review of some things that you've probably already learned in geometry. Let's say that we have a right triangle. And let's say that we know this angle is 40 degrees. We know that this hypotenuse is 4, and we want to know how long this side is. Okay. How do we do that? Well, we go back to our SOHCAHTOA, and we say, okay, if this is my angle, this is the opposite, that's the hypotenuse. Opposite and hypotenuse is sine. And we say the sine of 40 degrees equals x over 4. We multiply by 4 on both sides and we've solved for x. 4 times the sine of 40 degrees. But what if the x was down here? Okay. Well, now this is the adjacent. That's the hypotenuse. We are switching from sine to cosine, and we would say the cosine of 40 degrees equals x over 4. Okay, adjacent over hypotenuse, x over 4, multiply by 4 on both sides, and we've solved for x. Now, we might also need to use tangent, and tangent would have to involve opposite and adjacent, so it might be something like, I don't know, like let's say this side was 4 and this was x. Now it's an opposite and adjacent ratio, so now we're at tangent, and we would say the tangent of 40 degrees equals x over 4, opposite over adjacent, multiply by 4. 4 times the tangent of 40 degrees equals x, and we've solved for that side length. Okay, so working with right triangles is pretty easy. But what we have to talk about now is what if it's not a right triangle? Let's say this is 40, this is x, and this is 4. Yeah, how are we going to do that? And that's really what our last few days here, our last 3 days, are going to be focused at, is how do we solve for side lengths and angle measures if we have triangles that aren't right triangles. The word oblique will be used sometimes. Instead of saying not a right triangle, we'll say oblique triangles, but this is what we have to do. So then how do we do that? Well, I hope if you thought about this for a second, you would say, if I know how to solve with right triangles and I have an oblique triangle, can I make my oblique triangle into 2 right triangles and work on that? So that's exactly what we want to do, is we want to make our oblique triangle into 2 right triangles and work with that. And to do that, we're going to learn something here today called the law of sines. So what I've done is I've taken a triangle here. Okay, it is an oblique triangle, not necessarily a right triangle, it's oblique. And all I've done is I've dropped down in altitude a perpendicular line from the vertex to the base to split it into 2 right triangles. Now, we are calling the angles, the vertices, A, B, and C. Those are going to be our angles. Now, one thing that we have to know is how we name the side lengths. If this is angle A, side A is opposite. This right over here would be called side A, and the side lengths are lowercase letters. The angles are uppercase, the side lengths are lowercase. So here's angle B. This would be side B right here. Here's angle C. This is side C right there. And I'm going to call this altitude that I drew in H for height or altitude. And here's what we're going to notice. What is the sine of angle A? Well, if we looked at the entire triangle, we can't use the sine function because it's not a right triangle. However, because we've dropped in this altitude, we can now find what the sine of angle A is. And if we take a look at this and we look at just the triangle on the left, the height is the opposite and B is the hypotenuse. So the sine of A equals H over B. Now, how about the sine of angle B? Well, now we're looking at the right triangle on the right side. Opposite hypotenuse, the sine of B equals h over a. Now, when I look at these two equations, I notice that they both have h's in them. And if I multiply by b on both sides, in this one, I get b times the sine of a equals h. And over here, if I multiply by a on both sides, I get a times the sine of angle b equals h. And what do we have here? H is in both of these. So what does that mean about b times the sine of a and a times the sine of b? It means they're equal to each other, aren't they? So we can set b times the sine of a equal to a times the sine of b. Okay? Those two things are equal. And from this, we can derive our law of sines formula. I'm going to divide this, both sides, by the sine of a. And I'm also going to divide both sides by the sine of b. Notice here the sine of a's cancel, over here the sine of b's cancel, and we get this equation. B over the sine of angle b equals a over the sine of angle a. Okay, we get a proportion. Okay? And that can actually be extended one more way. If I redrew my triangle and I set it up and I drew in a different altitude, we could end up with a third part of it too. And here's our law of sines. A over the sine of a equals b over the sine of b, which equals c over the sine of c. So let's say I know these three pieces of information. I can find that one. Okay. Let's say I knew these three pieces of information. I can find that one. Okay. We can either set these two equal to each other. We could set these two equal to each other. Okay. We could set this one equal to that one. There's a lot of flexibility here for whatever we need. Now, again, I'm just going to draw this in here so we don't forget. How are we labeling our triangle? Angles are A, B, and C. Side lengths have to be opposite their angle. This is side A, side B, side C. So let's look at one of these. Solve triangle ABC if angle B is 36 degrees, angle C is 87 degrees, and side A is 10 degrees. So what I have to do is I have to put this information together in a triangle. To solve the triangle means I need to find all the side lengths and all the angle measures, which is what we'll do. Now, we have some angle measures here, and typically I don't get too interested in drawing a very accurate drawing with those angle measures yet. Usually I like to map it out and kind of get a feel for it, and then if I need to redraw my triangle to better match the measurements that are given, I'll do that. But let me just draw a generic triangle. And let's just label it ABC. Then I'll put my side lengths on. And now let's put in the measurements. B is 36 degrees. C is 87 degrees. And side length A is 10 degrees. Now, looking at this, this probably shouldn't be my 36 degree angle. That looks more like this one. So I'm going to switch where A and B are located. I'm going to put my 36 there. I'm going to call that B. So that switches this to A, and it's going to end up switching all of the side lengths here. So A is 10, this is B, this is C. Okay, so I feel good about my sketch. And now let's solve the triangle. So what do we need to find? Well, we are missing two side lengths and we're missing one angle measure. I think the angle measure is going to be the easiest to find here because we know the sum of the interior angles of a triangle is 180 degrees. So I'm simply just going to take 180 minus 36 minus 87, and we have 57 degrees right here. Okay, that was the easy one. Now, how about the side lengths? Well, let's start with side B. Now, if we look back at our law of sines, side B is here. We have to know the sine of angle B. Do we know angle B? Yes, we do. It's right here. So I'm going to say B over the sine of angle B. So B over the sine of 36 degrees is equal to, now I need to put another side of the proportion. And I can either use this one or I can use that one. Depends on the information that I have. So let's look at the information that we have. What side length do we know? We know side A. We also know angle A, which allows us to use this one. We can't use C over the sine of C because we don't know the length of side C. Okay? So we have to use this one. So we're saying B over the sine of angle B, B over the sine of 36 degrees equals A, 10, over the sine of angle A, which is the sine of 57 degrees. There's my proportion. Now we can solve this. All we have to do is multiply by the sine of 36 degrees on both sides. And we get B equals 10 times the sine of 36 degrees over the sine of 57 degrees. Okay. And I'll just grab my calculator. I'll make sure my mode is in degrees, which it wasn't. So there we go. So I'm just going to type in 10 times the sine of 36 divided by the sine of 57. And voila, it's about 7.0. All right, so we've got that one. Now let's find side C. Well, if I want side C, I have to start with side C over the sine of angle C, which is 87 degrees. C over the sine of angle C equals. Okay. Now what am I going to set this equal to? Okay. Well, we're using this one. Okay. So are we going to use this or are we going to use that? Well, let's look back at what side length we know. Well, now we actually know both of them. We know side A and we know side B. However, the 7.0 is rounded. I don't want to use a rounded side length to do more calculation. I could use the exact length, but that gets messy. Using the side length of exactly 10 is going to be much easier. So we're going to do A, which is 10, over the sine of angle A, which is the sine of 57 degrees. And there we go. Now let's multiply by the sine of 87 degrees on both sides. And we get C equals 10 sines of 87 degrees over the sine of 57 degrees. That's the exact side length. Now let me type it in. 10 sines of 87 over the sine of 57, and we get about 11.9. And we have just solved that right triangle. So that's one example about how the law of sine works. I'll stop the video now and then we'll learn some more about it in the next video.